So it's really x to the fourth minus 8x cubed plus 15x squared plus 4x minus 20. So A says find the zeros, B says determine end behavior, and determine multiplicity. And then you're going to sketch the graph. So remember when you're doing zeros, and it's been a week probably since you've done that, well, some of you, all the factors of 20, 1 and 20, 2 and 10, 4 and 5, and that's it. So I have 6 numbers that divide evenly into 20. The factors of my coefficient on the front are just 1, so I don't have to worry about doubling all those. So my possible list of factors are plus or minus 1, plus or minus 2, plus or minus 4. And remember, your job is to just pick a number and start testing it. When you find one, let us know. So I'm going to start with that.
2 works.
2 works as well? Well, look at there. So you're doing synthetic division when you find the zeros.
You said 1 or
Negative 1. So you take all the coefficients out of your expression and make sure you leave any placeholders filled in. 1x to the fourth, negative 8x cubed, 15x squared, positive 4x, and negative 20. Watch your signs on all those. 24. Negative 20. Oh, good. Negative 20. Okay, so I found one. Once you find one, it shrinks your expression. Now I can do all the rest with just 1, negative 9, 24, and negative 20. So every time you find one, it shrinks your expression, your equation. So now when I go to the next ones, so I would start maybe next with the number 2. So I'm going to go 2 into, now I can use these new 4 numbers. I don't have to go back to the original equation. I can go to the shrunk equation. And you don't include the 0 at the end, because that's a remainder of 0 plus 0 doesn't change. Negative 14, 10. Well, that's exciting news. So we got another one. X equals 2 is another one. I'll let you write that down before I shrink it. Oh, let me pause. And now we're coming to the end of the problem. Nothing has happened. Again, in between. So let's not talk about states and territories. Once it is factored, remember, set each parenthesis equal to 0 and solve it. That's how I got positive 2 and positive 5. So look what happened. Avery, yes. I knew it. Double root. See that? 2 appears twice.
Touch and go.
Touch and go. On number 2. That's what Weaver wants to do right now. But he has 3 minutes left. And so, okay, so I have to, let me shrink and move. That'll be good. Touch and go, shrink and move. So I have 4 numbers it looks like. However, when I graph them, I've only got 1 dot at negative 1, so I'm going to put a dot there. I have a dot at positive 2, and it's a double root, so I know it's going to be a touch and go, but I don't put 2 dots. 3, 4, 5. So I have a dot at 5. I'm going to move that stupid thing. There we go. Okay. End behavior. I started out with a positive x to the fourth. The end behavior is the left and right side will then both be going up. They're going the same direction because it's an even root. Even means same direction. And then it's a positive in front, so that means they're both going up. It's crossing at negative 1 because that's a single root, so it does cross. And it's got to eventually loop back up so it gets to the second dot. But that's your touch and go. So it touches it and then it goes back down. And then it crosses at 5. So single root, cross, double root, touch and go. End behavior tells you those two. All right. So I'll do the rest of them.